Hello everyone, good evening. So let us look at two examples on shell method. Let us take note of the formula for the volume of a cylindrical shell. It's given by this 2 pi r h times delta r. So two different cases. Case number one is when the generator is revolved with respect to y-axis. If that is the case, then the volume is just 2 pi integral in terms of x times the height of the shell from A to B. Case number two is when the axis of revolution is the x-axis. So the volume is integration with respect to y of y times the height of the shell from C to D. So let us look at this example. If you notice, for part A, start with part A. This is the solid of revolution. So I think this should be y-axis. This one is y-axis. So in other words, the region or the generator is this part here. For part A, this is revolved with respect to y-axis. So the solid on the given solid will match the given, and this should be x-axis. So let's proceed. So the shaded region is revolved with respect to y-axis. So if that is the case, in other words, our rectangles must be vertical, since we will be revolving it with respect to y-axis. So the volume is 2 pi integral of x times this height here is line. It's line minus this curve. So in other words, this should be 2 minus x minus x cubed dx from 0 to 1. It's from here, from 0 to 1. So let's continue. I have here 2 pi integral from 0 to 1. Distributing, we have 2x minus x squared minus x to the fourth dx. 2 pi, antiderivative is 2x squared over 2 minus x cubed over 3 minus x to the 5 over 5. Evaluate from 0 to 1. 2 pi, when x is 1, take note this is already 1. When x is 1, we have 1 minus 1/3 minus 1/5. When x is 0, then this is 0. Simplifying, I have 2 pi. LCD is 15. I have a 15 minus 5 minus 3. So this is 2 pi times 7 over 15. Therefore, the volume is 14 over 15 pi cubic units. That is for A. Now, let us look at, this is done, letter B. So as I have said, this is y-axis. So it will match the given solid on the screen. So the generator is this part here. This time we will be revolving it with respect to x-axis here. So since we will be revolving it with respect to x-axis, our rectangles, or yes, is horizontal. But notice that if I will have rectangles here in this portion, the height is different, right? Different from here and from here to here. So in other words, the volume is defined as 2 pi integral from 0 to 1, 0 to 1 of y times, for this part here, the function is y equal to x cubed. So x is cube root of y. So I have cube root of y dy plus, for this part here, from 1 to 2, so I have 2 pi integral from 1 to 2 of y times, the rectangles here has height y equal to 2 minus x, which I can rewrite as x equal to 2 minus y. So this is 2 minus y dy. Let's integrate. So this is 2 pi 0 to 1. This is y to the 1 times y to the 1/3, so that is y to the 4/3 dy plus 2 pi integral from 1 to 2 of 2y minus y squared dy. So 2 pi integral from 0, oh sorry, let's integrate now. So I have y to the 7/3 over 7/3, evaluate from 0 to 1, plus 2 pi of 2y squared over 2 minus y cubed over 3, evaluate from 1 to 2. Let's see. So 2 pi times 3/7. When y is 1, I'll have 1. When y is 0, I'll have 0. Plus 2 pi here. This will now be 2 over 2 is 1. So I'll just have y squared. When y is 2, I have 4 minus 8/3. Minus, when y is 1, I'll have a 1 minus 1/3. Okay, let's go up. So what is this now? Here 2 pi times 3/7 is 6/7 pi plus 2 pi times 4 minus 1 is 3, negative 8/3 plus 1/3, so I have negative 7/3. And now plus 2 pi times 3, 9 minus 7. Oh, how much is this? What is this? 6/7 pi plus 2/3. So I'll have 4/3 pi. Then 21 here. 21 divided by 7 is 3 times 6 is 18 plus 21 divided by 3 is 7 times 4 is 28. So therefore, the volume is given by 18 plus 28, that is 1646 over 21 pi. That's it. Good night, everyone. Bye.